In this section, I'm going to talk about static routes. Now, how you can configure static routes and why do you want static routes are discussed in this section. So, in my sample network, I can send some frames from router 1 to router 2 or to router 3 because these two routers have interfaces that are in the same subnet as my interfaces. For example, I have path 00 connected to router 2's path 00, and these two interfaces have the same configuration, the same subnet configured on them. So if I want to send a packet to router 2, I know which subnet is attached to which interface of me, and I will send that frame through that specific interface. For example, if I want to send a packet to router 2, I will send it through path 00 because I know router 2 is in this specific subnet. I can guess it from the subnet ID of the destination of the frame that I'm sending. And then, because I know this subnet is attached to my path 00, I will send that packet through path 00. And that's easy. But I do not have common subnets with router 4, for example, because router 4 is not attached to me, does not have a direct connection to me, and I don't know how to send my packet to router 4. So I need to know what routers are in between me and router 4. Then I will statically be configured to send my packet to those routers in between me and router 4. So those routers have common subnets with router 4 and will forward my packet to router 4. In this example, router 2 is between me and router 4. So if I want to send the packet to router 4, I will send it to router 2, and router 2 has a common subnet with router 4 and will forward my packet to router 4. Now, if router 4 wants to send me a packet back, that would have to know the routers between it and me. So router 2 again is in between me and router 4, and router 4 will send its packet to router 2. Router 2 will forward it back to me. So this is a two-way configuration. If I know a route to some destination, that doesn't guarantee that that destination knows the route back to me. So I have to configure static routes on router 1 and router 4 so that these two can, communicate to each other. Now I want to show it in action. I start my routers first, and I go to router 1, and first of all, I want to check the routing table and see which destinations are available to me. I go to privilege mode to have the full features of the commands. So I show IP route, and this will tell me which route are installed in my routing tables. And you can have a legend in first, and you should be familiar with some of these. For example, C is for connected, S for static, and other routing protocols have their specific flags. You can see that now I only know some connected networks to me. I have interfaces that are in 10.0.12 and 10.0.13, so I can send frames to these interfaces to reach to these subnets. I cannot reach any other subnet. For example, if I want to reach router 2, I can ping, for example, 10.0.12.2, and that's successful. And you can see this. But if I want to send packet to 10.0.24.4, that's the subnet that is attached to router 4, and you can see that this will time out because I do not know how to reach this. I press Ctrl-Shift-6 to abort this ping, and now I want to start the debug to tell you why this is not happening. Start debug IP packet, and this of course noisy debug, but for now I want to see some results. And now I repeat the ping, but with just one repeat. I type repeat 1, and this tries to send the packet to 10.0.24.4. And you can see that this tells me this packet is unroutable because I have no entry in my routing table that shows me where to send this. So now I have to provide a way to send this packet to router 4, and I know that router 2 knows the way, path to router 4, and I know the path to router 2. So I should tell these frames to go to router 2, and because router 2 knows the destination, it will forward it for me. So I start configuring a static route. I go to configure terminal configuration mode and start adding a static route. So I add IP route and I say I want to send a packet to 10.0.24.0 subnet and any destination in this subnet, and this is a 24-bit prefix. And now I can do two things. I can tell which interface these packets should go, or I can tell which destination it should go. I will try both of them. I want to say if you have such packet, send it through fast00, because fast00 goes to router 2 and router 2 should know the way to router 4. Now, just as I told you, because I know the way to router 4 does not mean that router 4 knows the way back to me. So I have to do the same thing on router 4 and tell router 4 how to reach back me. So I go to enable mode and I go to configuration mode, and now here I add this IP route. I tell if you want to go to 10.0.12.0 subnet, and this will be a 24-bit prefix, you should use fast01 to reach to that destination. Okay, now that I have introduced this, let's check our routing table. The show IP route will tell me that I have a static route here that is flagged with S, and it goes through fast00. So I have to look at my routing table once and know which way to send my, or which interface to send my frame through. So now I try to ping again, 10.0.24.4, and now you can see that this ping is of course failing, and you can see this is a noisy debug and gives me a lot of result. Of course, you can see that this ping is going to be successful after a second. The first one failed. Now I undebug everything by do undebug all and try to ping again, and you can see that the ping is successful. Now let's check our debug. You can see that first time encapsulation failed because we did not have any ARP entry to show us which way to send this. But next ones are successful because we know how to send this packet. So we send this packet to this subnet, and this subnet connects to router 2 sees that frame and knows the destination, so forwards that for us, and router 4 now can send it back to me. So instead of using interfaces for routing, we can use destinations to add static routes. Let's first check our ARP entries by show ARP, and you can see that I have of course 10.0.24.4, and this entry is the same as this entry that goes to router 2. So to send the frame to router 4, I encapsulate it with a destination MAC address that goes to router 2 because I know that router 2 is in my way to router 4. Okay. Now I want to remove the static route here by negation command, and again I hit Control A to move my cursor to the first to the beginning of the command, and I hit Control W to remove a word. The word is no. I hit Control E to go to the end of command, Control W to remove a word, and now I want to add a destination IP address. That's 10.0.12.2. So whenever I want to send a packet to 10.0.24 subnet, I will send it to 10.0.12.2 and hit enter. I want to do the same on Rutherford. Of course, this is not necessary, but I want to have a consistent communication here. So I hit Control W here and add 10.0.24.2. And now the ping should be successful again if I want to do this from router 1. To do this, I try the ping. And you can see that the ping is successful again because I know the way, I know the route to send my frame to Rutherford, and Rutherford knows the way back to me. So these are easy things to do, and you can easily add static routes. And I want to do this in advanced sections of my routing in CCNP levels. But here, this is quite enough for me. Now, this is very easy to do such things, but whenever you start growing your network, this will be very cumbersome and very hard to configure static routes because it is very hard to manage, and you should know each way, and you should configure static routes on each router to be able to send frames through. This is why we should go through dynamic routing protocols, and I want to start by RIP in next section.